In this chapter, we are going to look at progressive waves. So a progressive wave is defined basically as a wave, or it is a disturbance which moves from one source to another, or from one source to the surrounding places, and transfers energy in its motion along the way. So basically it is a wave which is in motion from the source to the surrounding places and transferring energy from one place to another. So some of the examples of progressive waves, we have water waves, they are progressive, and all electromagnetic waves are progressive. Then longitudinal waves, all of them, and transverse waves, they are also progressive, and the amplitude of the progressive wave is always constant. That means that as the wave moves, the displacement from the mean position is always constant. So if you look at the energy which is transmitted in a wave, of course, we know that as a progressive wave moves, or as it is propagating from its source, it moves to a certain direction, and therefore it transfers energy as it moves. So that means that every particle of the medium possesses energy, and that energy is due to the vibrations of the individual particles of the medium. So the energy keeps on being passed from one particle to another in the system, and therefore the form in which the energy is being transferred, or the wave is vibrating, or it vibrates in a kind of motion, or it moves in a kind of motion that we call simple harmonic motion. So meaning that the energy will keep alternating from kinetic energy to potential energy, but the mechanical energy will remain constant. So this implies that as the wave propagates, the mechanical energy is conserved. It is only energy changes from kinetic and potential that keep on occurring, though the total mechanical energy remains constant. So the kinetic energy of a wave can be given by the formula. Kinetic energy is given by the formula half mv squared. This is the general formula for finding kinetic energy. But of course, for this wave, for a wave which is progressive, it moves in, it exhibits simple harmonic motion, or its motion is simple harmonic. So this implies that the velocity v will be given by omega a, where omega is what we call the angular frequency. So angular frequency omega is given by omega is 2 pi f. So omega is called the rate of change of angle, and it is 2 pi f. So if we substitute for 2 pi f in v, that means that v will be equivalent to 2 pi f a. 2 pi f multiplied by a is the amplitude of the wave. So if we substitute v in the formula of kinetic energy, we shall end up having kinetic energy as being equivalent to, we end up getting kinetic energy being equivalent to this equation here. So this is the equation for kinetic energy if you substitute these ones here. So F, of course, is the frequency, A is the amplitude, and M is the mass of the vibrating particles. So if you want to get the energy per unit volume, that is E out of V. So it means that now we have now to first determine the volume. So the volume, we know that from the formula of density. Density is mass over volume. So this implies that the volume will be given by mass divided by the density. So meaning that for volume, we shall use mass over density, and we shall end up having the energy per unit volume will be given by 2 pi f squared. This one here is the energy, and then the volume is mass divided by density. So finally, the energy per unit volume will be given by 2 pi squared f squared. Of course, m will cross s squared, and then multiplied by the density. So this is the formula of energy per unit volume of the wave. So the other one is the intensity of the wave, and this is the rate of flow of energy through an area of 1 meter squared perpendicular to the path of the wave. So basically, these are the important terms that we need to know about a progressive wave.